Okay, so moving on. So same topic, slightly different angle of look. All variables have pretty much two fundamental properties available to them, which is basically the address of the variable and the size of the variable. In fact, it's very easy to get to the size of the variable. You can say that, for instance, let's print another line here. Size of a value is, and we're going to just print the size of value. And there's an operator, it's called size of, right? So size of essentially takes a look at the name of the variable, any variable, at compile time, and the compiler always knows what is the size of that variable, because it doesn't change. If your integer is 32-bit in size, it's just going to be 32-bit in size for the duration of its lifetime. It's not going to get smaller or bigger. It's just going to stay this way. So let's give this a try. Okay, you can see that. Oh, I'm calling it twice. Let me just remove the second call so that we just just calling it once. Okay, good enough. I run it again, and so it says the size of value is 4, which tells me that this compiler measures sizes. The unit of measurement of things in memory is actually 1 byte, because I know that in this compiler my integers are 32-bit, so which means that it basically measures things in terms of increments of 8, which is 8-bit is the size of 1 byte. Okay, so to jump ahead of this, in C, a byte is represented by a character data type, char, C-H-A-R, and it's usually is the smallest addressable thing that you can make part of your program, essentially your data type. So anyway, so a character would have, so let me demonstrate this, right? So if I say character CH equals, I'd like to initialize it with uppercase A. Note single quotes, right? So individual characters, to disambiguate them from string literals, which are sequences of characters, use single quotes, not double quotes. So I can create character, initialize it with character A, and then do the same thing. I can say size of CH is size of CH, right? So we can find out pretty quickly what the size of CH is, and not a surprise, size of CH is 1, because character is just 1 byte in memory. Even more, sometimes this can be somewhat confusing, that in Java, character, since many of you are taking Java course, character in Java is 2 bytes to facilitate internationalization of your programs. It's more open to the idea of larger value, a larger variety of characters that you can have. But in C and C++, character is just 1 byte, which of course can hold only values from 0 to 255. So the value of character encoding A is actually decimal 65, right? To demonstrate, I could replace this line with CH equals 65, which would be my guess that this compiler and platform is using specific character encoding. So if I run this, we can do, we can actually display ch is, right? And we can print what ch is by adding another part of input, or output, and just basically ch is ch, comma, right? And size of ch is, right? So let's do that. We have to build every time we make a change, and then we run it. It says, as you can see, my guess was correct. The encoding of uppercase A character is 65, and when I print it, it still gets printed as character A. And the size of ch is 1, because character in C and C++ is taking one byte in computer memory. So sizes are absolutely unique to variables, and they're absolutely unique to variable types. I may as well do the following. I may say that I don't even need to have a variable to tell you how big the character is in memory. I can basically say char size is, and simply say, hey, what's the size of char of the character data type? Size of is extremely friendly with the actual data types and the variables. It just simply goes out and says, okay, what's the size of character? And it knows. What's the size of a variable? And it knows. By the way, the value and other local variables that we use here are not the only variables. In fact, stdcout is also a variable which represents the object. So we can say then that, let me just fix that for you, and we can say that stdcout size is this, and we can say, hey, cout, what's your size? How big are you in memory? That's interesting. Let's run that and see what that comes out as. 80 bytes, right there, people. 80 bytes. It's not terribly big, right? Only 80 bytes that cout allocates in your memory. Okay, of course it interacts with other components in the system, which could be larger, but its own little working needs 80 characters in this specific on this specific platform to operate. So measuring sizes of things is extremely straightforward. Okay, what other very useful thing you might find is actually also asking variables, what is your address?